Okay, you're welcome once again to Things Top Notch Academy. We're still under differentiation, and we have treated these methods of differentiation being general methods, first principle method, and today we're going to look at the chain rule, which we call function of function. So let's take this chain rule as what we're going to discuss today. So So the chain rule is what we use when we are differentiating a particular function that has another function. You understand? That's why we call it function of function. So unlike when you have y equals to what? Else. Let's say 2else. So you don't need to apply chain rule to solve this. But let's say you're given y equals to 2x plus 1 all raised by 5. So you need that to apply the chain rule because this is a function of a function. All right, we already have a function here, and this is also a function. So we'll call it a function of what? A function. And that's why you need chain rule in order for you to get the right answer. Okay, so just make sure you follow with me as I solve the examples that will help you understand how to apply chain rule in differentiation. So the chain rule, you may have seen something of this kind. dy over dx equals to dy over du multiplied by what? du over what? dx. You may have seen something like this, and you may not be able to know what it looks like or what it implies because you've not been taught. And today we're going to look at this chain rule, and this a whole of this is what we refer to as what? The method that we call chain rule. So I'm going to walk you through these steps on how you apply this to get the answer that you are expected to get on differentiation. Now, to look at some examples, or just look at a single example depending on the time that we're given. So, example. Let's say we are asked to differentiate y equals to bracket let's say 2s plus 1 all raised by 6. Okay, using chain rule. So when you ask to differentiate something of this type, so we just write solution, then we are given y equals to 2x plus 1 equals to what? Raised by 6. This is what? Given. Okay, so you know that this is a function of function because it is a function that depends on another function in order for it to have its value. So what do you do now? You cannot say let 2s raised power, okay, let's say let u equals to 2s plus what? 1. So if you assume the whole of this, that's the method. Anything that is inside the bracket is assumed to be what? U. You may not actually use U. You can use any other alphabet to represent that. But I choose to use U. So now you have y is equal to what? U raised power what? 6. Okay? So now you can find dy du. You find the differentiation of y with respect to u, and also you need to find the differentiation of u with respect to what? Else. That's just it. And after you've gotten their differentiations, so you now multiply them together to get the answer, which is dy over what? Ds that you're expected to get. So dy over du which is differentiating y with respect to u, is going to be this u now will come down, which is 6 u raised power 6 minus 1. which is also going to give us 6u raised power what? 5. Alright? So that's what we got from dy over du. Let's solve for du over what? Dx. Du over df is equals to, if we differentiate s here, it's going to give us 1. So 1 multiplied by 2 is what? 2. Then plus, then differentiating a constant is 0, which is going to give us what? 2. Okay? Don't be confused that I said if you differentiate s is 1. Remember that we have s 1 raised power 1 as the value of as s here. So if you are differentiating, 1 will come here, it will now be 1 multiplied by s, then raised power 1 minus what? 1, which is 1 multiplied by s is the same as what? S raised power what? 0 is the same as what? 1, because they say any number that is raised to the power of 0 is what? 1. That's what indices says. So if you've not watched the video, just check indices video. It's on the playlist. Check indices, you understand what I mean here. Now, having done that, we can now say dy, because initially we're given that y is equal to what? 2s plus 1 all raised to power 6. So we're given that two s plus 1 raised to power 6. So now we are expected to find the y over what? The s from this. You know, when this equation was given, there was no u. So what they expect us to find is dy what? With respect to what? The s. And how do we get this dy with respect to the s? We have to introduce u, which is what we've done. And now we can now have our dy over what? The s as. So now is dy over du, dy over what? Du multiplied by, or use this. Then next one is du over dx, du over what? Dx, such that if you want to still get the dy over dx you're expected to get, if you cancel the u going against the u, it will still remain dy over what? Dx, which is what you're seeing here. So in this case now, you're going to have dy over dx is equals to, we got dy over du as this, which is 6u raised to power 5 multiplied by, then we got du over dx as what? 2. So now what you need to do is multiplying this together, we are going to have dy over df is equals to 12u raised to power 5. Then we can now recall that we were given u to be 2s plus 1. So if we substitute the value of u, we will now get to have dy over the f is equals to 12 bracket 2s plus 1 raised to power what? 5. Alright? This is the method that you're going to apply to solve this problem. So maybe next time I will also give you the shortcuts that you apply when you are solving this chain rule to get your answer very fast without going through all this process. All right, just make sure you stay subscribed if you subscribe, and if not subscribed, make sure you subscribe. All right, hit the notification bell so that whenever I upload video you will be notified. Thank you and remain blessed.